Hello, everyone. Welcome to Full Sales Tech Tuesday. My name is Dr. Leis, and today we are talking about behind the bots. We're going to review Full Sail core teaching disciplines related to things like programming, AI, simulation, and we're also going to talk about FIRST Robotics and our upcoming FIRST Robotics Competition. Like I said, my name is Dr. Leis. I am the Program Director for Computer Science, User Experience, and Mobile Development here at Full Sail University. And I am joined today in the studio with Desh and Jane. And then we're also joined online with Daria and Erica. So I'm going to hand it over to Desh. Why don't you introduce yourself?
Thank you, Bex. Hi, everybody. My name is Desh Bagley. I am a program delivery partner for FIRST LEGO League Robotics. We are an international program. I'm also an associate dean for AS and science programs at Hillsborough College in Tampa.
All right. And we also have Jane joining us, correct?
Yes, so this is Jane. Jane is a humanoid robot. Jane, why don't you go ahead and introduce yourself to everybody?
Hello everyone, I am Jane, a humanoid robot designed to help students explore the world of STEM, programming, and coding. I have a variety of sensors that help me interact with my surroundings, including cameras for vision and microphones for hearing. My connectivity to the OpenAI API allows me to access a wealth of knowledge and engage in meaningful conversations. I aim to make learning about technology fun and accessible. It's great to be here with you at Full Sail University. Let's dive into the exciting world of science and technology together.
Thank you, Jane. All right, we also have Daria and Erica on Zoom. Daria, why don't you introduce yourself?
My name is Daria Bagley. I'm an intern with the National Center for Simulation, and with that is a duty of being a co-coach for the STEMLens and FIRST LEGO League Challenge team. I'm also a student at the University of Central Florida. I'm a junior majoring in criminal justice and minoring in national security and intelligence along with terrorism studies.
Fantastic. All right, and Erica.
Hello, my name is Erica Restrepo. I am a co-coach for the STEMLens FIRST LEGO League at NCS, where I am also an intern. I'm currently a freshman at Valencia College, majoring in mechanical engineering.
Fantastic. We are also live streaming today from YouTube, Facebook, and LinkedIn, where you can watch and the recording later on as well. So let's start out. We'll dive into some technology, and we'll actually start out with FIRST Robotics. What is FIRST Robotics, and how did it come about? And we'll talk a little bit about like Dean Kamen, and we have a video in just a second. So let's first talk about FIRST Robotics.
Okay, so for me, FIRST Robotics came into my life when I started a small business called Tech Play Zone. I had gotten my degree late in life, my Bachelor of Science degree. I got it late in life. In fact, I think I had my third son by the time I finished that bachelor's. And I thought, what would it be like to start a business where I could actually hang out with the kids and do things that we all love? And of course, I love robots. And so I discovered FIRST as an international program, and my kids were like, we want to play with robots. What's this all about? So 5 kids later, 15, 20 years later, I am a program delivery partner for a 19-county region. FIRST LEGO League was started by Dean Kamen as a way of getting young people excited about science, technology, engineering, and math. Dean says that we should celebrate our STEM stars just like we celebrate our athletes and our actresses and actors on TV.
Oh, yeah, science rock stars, for sure, yes. So we actually have a video here to talk a little bit about FIRST Robotics.
This isn't a robot. It very well may have hydraulic arms, a drivetrain, and a circuit board, but this isn't a robot. This is a lesson in humility, hard work, and collaboration. This is a CrossFit workout for the muscle upstairs. This is an apple for the next generation of Newtons. It's a lot of things. But this isn't a robot. This is a roadmap that leads straight to engineering. This is a rock to shatter 1,000 glass ceilings. A rope to pull a generation up and out of poverty. A sledgehammer to break down cultural barriers. And a universal language spoken in every nation on Earth. And because of that, this is a compass that can help point the way to peace. But please, don't think this is just a robot. This is Glastonbury for technology. This is mission control for the next moonshot. This is the Rosetta Stone to help translate the future. This is the sport that will help us win tomorrow. This is the software to program ourselves to cure cancer, build a clean engine, or step foot on Mars. But this isn't a robot. It's a machine to build the people who will change the world.
Oh my gosh, I love that video.
Yeah.
That's exactly what it is. For FIRST LEGO League and FIRST Tech Challenge and FIRST Robotics Competition, it's all about using robots to build kids, not kids building robots.
I know, right? And I was getting like goosebumps watching that video. So inspiring. Okay, so let's talk about the different levels in the FIRST ecosystem. So for those that are not familiar, where does LEGO League land in that, and what are some of the other levels within the FIRST ecosystem?
Well, to start off, FIRST is an acronym, and it's for Inspiration and Recognition of Science and Technology, FIRST. And there are levels from pre-K, actually, all the way to 12th grade. Our program that I work mostly with is FIRST LEGO League, and it starts in pre-K, goes all the way up to 8th grade. And what's wonderful about FIRST LEGO League is that it really is a collaboration between LEGO Education and FIRST. So all of the robots that the FIRST LEGO League kids build are Lego-based robots, Lego-based microprocessors, Lego sensors, which I'm looking forward to talking about that. The next level, we call it sort of junior varsity, FIRST Tech Challenge, and that's middle school through 12th grade. And the final biggest level, which is sponsored by major corporations around the world, is FIRST Robotics Competition. And that's 9th grade through 12th grade. We call it the varsity of robotics. Yeah. And it's where lots of colleges, even Full Sail, offer students scholarships for participating in the FIRST Robotics Competition in high school.
Awesome. So how do you see events like our upcoming Full Sail competition inspiring students?
Oh my gosh, Bex. On December 13th from 9 a.m. to 3 p.m., we are having a FIRST LEGO League competition in the Full Sail Live. And if you've never seen that building, it is phenomenal. We're going to have 24 teams compete for prizes, awards, and the ability to advance to the regional championship. And at the same time, we're asking everybody to come out and celebrate with the kids. It's a competition, but it's really a celebration of what they've been doing all season long. Mm-hmm. It's free, it's open to the public, and we invite everybody to come and watch.
All right. That sounds so neat. I'm super excited for the event. Again, December 13th, right? So let's talk a little bit about robotics and some of the ways that you can get involved and get prepared for something like a competition. So what types of hardware or kits would your students be using to build robotics?
So I'll start with FIRST LEGO League. Mm-hmm. Everything that's involved with FLL is built by Lego. And we like Lego because it serves as a hook, right? Lego is an international brand, and so is FIRST LEGO League. The same hardware pieces that students are learning, gears and motors and actuators and light sensors and ultrasonic sensors, all of those same types of hardware pieces, our kids in Texas are learning, our kids in China are learning, our kids in France and Nigeria, they're all learning the same types of hardware pieces. And our industry partners like that. They love the fact that our 8 and 9 and 10-year-olds understand exactly what the engineering design process is and how they should be going about using the tools at their disposal.
Yeah, we actually have a faculty member right now working on a VR project an AR project, an augmented reality project related to Lego, and the students can manipulate bricks in a space, and they have to work together to build something, which is fantastic. So Lego, the love for Lego definitely lives on well into adulthood for sure. And you had mentioned, a couple different things, but what kinds of tool sets are they using? Like what kind of programming languages or environments are they working in?
Awesome. So First Lego League students start off with a program similar to Scratch, with that sort of block-based programming language. But at the same time, even if they're using those block-based programming languages, they're understanding algorithms, they're understanding loops and variables, and they're thinking about exactly what steps does the robot need to take in order to fulfill the mission on the table. The older students, maybe First Tech Challenge and First Robotics Competition, they're using Java and Python. Some of them are using Android Studio. So they're really focused in on those programming languages that are used in society and in industry today.
Yeah. But some of the kits, like say the XRP kit here, or some of the other kits, you kind of start out in a very, easy to digest way. It's very much like step by step. I know when I put together the XRP, they have a lot of videos there to help you along the whole entire way. And you said that they're using a program very similar to Scratch, where it's that visual scripting, very node-based, like drag and drop kind of things.
Looks like puzzle pieces.
Yeah, exactly.
Yeah.
So it helps with learning that logic very early on, especially if you're not familiar with the process of programming, which is exciting. But what other kinds of skill sets have you seen students kind of go into? We are talking a little bit about things like maybe biotech or healthcare. What other kinds of fields are you seeing students go into?
Well, the wonderful thing about FIRST Robotics is that every year there's a new theme, right? And so you think robotics, so you might think computer science, you think engineering perhaps. Well, our First Lego League students, and for me, I've seen it after 20 years of being involved with this, I've seen our students become doctors and meteorologists or submarine specialists, archaeologists. You'll learn more about what this year's theme is. It's archaeology this year, right? And so the kids are looking at a real world problem in any facet of society. It could be farming, it could be horticulture, it could be space. One year we had a great space odyssey, and students learned a ton. So as far as industries that we see our students going into, it's everything. It's manufacturing, it's retail, it's transportation with the self-driving cars, right? And of course, everybody loves, well, maybe not everybody loves AI, but AI is a thing.
Yeah.
And so a lot of students are looking at how can AI be used to help identify artifacts in this theme of archeology.
Right. That's so cool. I did a minor in archaeology, so I have a little bit of
Did you
but yeah,
really?
right. I'm super biased. I'm very excited. We have a really cool video later on that we're going to show a little bit about the projects that are going on. But essentially, the students are solving real world problems.
They are. That's
right?
the goal.
And real world problems can be a little bit complicated sometimes, right? And so you have to think about a lot of different components and learning how to scope, and we'll talk a little bit more about that later. The other thing, too, that I wanted to ask is, what are some of the unique things that student participants can expect, talking about things like international collaboration and the celebration of diversity?
Oh, my gosh, yes. So at our local level, we call it the local qualifier. That's what we'll have at Full Sail on December 13th. We're going to have a local qualifier.
Yeah, all right.
From those qualifiers, 35% of the top teams will advance to the regional championship.
Okay.
From there, teams will advance to the state championship.
Okay.
And from there, World Festival.
Yes.
At the World Festival is where teams come together from all over the world to compete. Yes, we're going to compete, right? But also to get to know each other, to learn each other's languages, to find out that they have more in common than they do differences. The fact that they're all trying to solve the same type of problems, but in so many more unique and diverse ways. The fact that they all had to build a robot in order to solve mission models in 2.5 minutes. They have to get as many points as they can for First Lego League, 2.5 minutes. The robots look different, but the kids who are solving them all face the same type of grit and persistence and resiliency, right? The not giving up mentality.
I love how First Robotics keeps that human component, that like human element in it, and coming together and collaborating on things and teaching students teamwork skills. That's fantastic. That's something that we love to see when students enter into the Full Sail ecosystem, that they're willing to work on a problem together as a group.
You know how hard that is sometimes, even
yeah.
as adults.
Yeah, right.
Right. So you think about those 7, 8, 9-year-olds all trying to work
Yes.
together to come up with a common solution. It's fun to watch.
Oh yeah. All right, so I'm going to hand it over to Daria and Erica now. How about we start with Daria? Can you walk us through how students go from idea to a working robot?
Yeah, so in First Lego League, we really stress the engineering design process. So whether it's building their actual robot, they're looking at the mission map that they have, deciding which missions they want to accomplish. So they're identifying maybe a problem or a route, and then they're designing their robot to be as best accessible to completing those missions as possible. Then they're communicating with each other about what they've done and actually creating the solution itself. And then they try it out. And it's a matter of trial and error whether or not it works out, whether they need to make changes. They look at what worked, what didn't work. And then they do the cycle all over again.
Oh, yeah, that's super exciting. Uh, so let's talk a little bit about the engineering design process, and we have some pictures to show. Kind of walking through some of this. Erica, how about you tell us a little bit about that design process and how you coach students through that?
Yeah, so we really just want to foster their creativity and have them explore all different kinds of ideas that they have. We don't want to limit them to just one possible solution. We kind of encourage that they go through failures and keep trying to make the robot run and complete the missions that they are trying to have it do. Yeah.
Yeah, so we've been talking a little bit about trial and error and going through the process and making sure that we are failing forward, right? And so that's one of the things that's really important, especially about robotics and also programming, is that a lot of programming is trial and error as well. And you're going to be doing what we call debugging about 80 to 90% of the time, trying to make sure that whatever it is works, right? And so that's really important to foster not only in kids, but also in college age individuals as well. And so it's really kind of interesting to see you all start with the earlier ages and then having us kind of foster that later on in the learning journey. So what are some of the most creative, you talked a little bit about different solutions and like not necessarily jumping to the first solution or like kind of expanding and being going outside of your comfort zone, right? What are some of the most creative and surprising solutions your teams have come up with?
So, going along with the theme of archaeology, after speaking with an expert and doing their own research, the kids decided they wanted to create a field storage robot so that they could house different artifacts that the archaeologists are digging up in the dig site. Something that was very interesting was when asked how this robot would travel and get around, there was an idea that it could have wings built onto it. So we discussed the possibility of how that would work, even the physics behind such a heavy object using wings, if it's something feasible or realistic, how you would just have something like that be incorporated into our robot. But there's definitely been lots of interesting ideas thrown out by the kids.
Yeah, and we were talking a little bit earlier. Desh had mentioned, at that point, like, are we talking about drones? Are we talking about helicopters? Are we talking about, more like a jet? Whatever it may be. Like, what do those wings look like? How does the flight happen, right? So that's really a cool and interesting way to kind of problem solve as you're trying to figure out a way to get something up in the air. We also do have a video of the archaeology project. And while we have that up, Erica, do you want to kind of talk a little bit about what they're doing in the project and give us some insight into it?
Yeah, so in their research project, they are trying to figure out what problems that archaeologists face in the dig sites, and they're trying to think of solutions to those problems. So the problem that they're focusing, or our team is focusing on, is the fact that they don't really have a solidified way to store and transport artifacts. Because
Mm.
when we were talking to an archaeologist and a goldfield during our research time, they had realized that they kind of just store them in bags and bring them to the site and to the labs. So they're thinking of ways to kind of store them in a fridge-like mechanic, because some artifacts do need to be stored in colder or warmer temperatures. So that's what they're kind of trying to maneuver through.
That's so interesting. And we talked a little bit about drones. One of the things that Full Sail is getting into more in the new year are going to be drone technologies. And thinking about how to add like a fridge component to a drone is kind of an interesting problem to solve. So good luck with your.
A Spike Prime robot. So it's really rewarding to watch them grow in these fields. And as they're growing, they're getting more excited about the work that they're doing. They start saying, "Wait, this is actually really cool," or "This is really fun." And you watch them because initially they kind of underestimate their own abilities. But as they're going through this program, they start to come into their own more. They're less scared to throw out ideas and stuff like that. So it's just really exciting to witness their own excitement as they're getting further into this.
How about you, Erica? What would you say is the most rewarding part of coaching?
Yeah, for me, it's just seeing their faces light up when they are able to get their code to work, or when they're just coding trying to figure it out. Because, like Daria said, they really do underestimate their abilities and their skills. And so, seeing them work through that and actually code, doing something that they've never done before, it's just really rewarding for me, seeing their faces light up when they're doing it and actually getting excited to code. Because in the beginning of the season, they were like, no, I don't want to touch the robot. I'm not going to code. And now they're fighting over who gets to code first. So it's really awesome to see.
That's wonderful. We often will reflect as instructors about what our favorite part of the process is, and our favorite parts of the job. And the thing that a lot of the faculty always say is the exact same thing. Like, watching people learn is such a cool thing. Like, seeing things click and having that aha moment. It makes the experience really fun and engaging to impart knowledge on other people, which is fantastic. Okay, so let's talk about how students handle challenges. How do you see that they're going through the competition, and what kind of challenges are they running into, and then how do they deal with those challenges?
On the research side of things, because with our team, I'm more research heavy with the kids, Erica's more robot heavy with the kids. So typically, the challenges they face are about incorporating different ideas. Like we were talking about earlier, they wanted wings on the robot. We're even talking about developing a light that can detect calcium so archaeologists can identify bones easier. So when it comes down to things like that, we typically just keep it to a democracy. We'll discuss the pros and cons of different ideas, and then we'll vote on which ones we'll start with. And then it's also just making sure we're encouraging them that this is just the beginning of our project. If there's time later in the season, we can try to incorporate more ideas. But typically, for the research side of things, it's just they're so creative. There's so many ideas being thrown out all the time. Of course, we do have a limited amount of time before a competition, so we tend to keep things to a vote to make sure people feel heard.
Yeah. So, Erica, what kind of challenges do you see the students run into?
Yeah, so from the robot side, the big problem or challenges that they run into is the actual coding and troubleshooting, trying to figure out how to fix the code. And for that, they kind of just lean on each other a lot. They do ask me and Coach Daria for assistance, but because some have past experience with code, they do lean on each other for hey, did you see what happened wrong? Or what do you think we could do to make that turn more or less? And so that is something that they do to combat those challenges.
Perfect. Yeah, we at the collegiate level, we generally will talk a lot about like pair programming and how to do programming tasks together. So it's really good to hear that they are doing that earlier. And we'll talk a little bit about AI and how you can use AI to pair program as well. We talked a little bit about challenges, but how do you see that they collaborate and what kinds of like teamwork skills are they working on?
Yeah, so like we were saying earlier, they definitely lean on each other a lot. They love to discuss their different ideas with each other. And once that gets started, honestly, it's kind of hard to get them to stop. They're constantly bouncing ideas off of each other. They're really excited to try new things. And then we tend to give them a role within the different projects that they're working on. So as a whole, they have roles like team captain, co-captain, research lead, programming lead, things like that. And then once they're actually working on the robot itself, they'll have a builder, a coder, somebody that's mapping out the different routes, somebody that's writing the pseudocode. And once they've got those types of roles, they tend to really find their like a cycle in that. And then, like Erica was saying, they'll lean on each other for, oh, you were writing the pseudocode. Which part of the code should we adjust here? Or, oh, you were working on the attachment. What do you think about building an attachment that's maybe heavier or something like that?
I love that you lean into their strengths. But I think, Erica, we were talking earlier about how you have them shift roles sometimes. Can you talk a little bit about that?
Yes, so like Daria was saying, we divide and conquer. And so when they go into their separate research and robot focused teams, we have them switch roles to get different perspectives on the coding, on the building aspects, and the writing of the code to generate more ideas. And so we really like to have them cycle through different roles so that they can get a feel and just kind of build their skill set.
I like that.
Yeah.
Building skill sets, especially at this early age. So remember, we're talking about, I want to say for their team, for Daria and Erica's team, they are 6th and 7th graders. So
We're
middle
actually fourth
schoolers.
through sixth grade.
4th through 6th grade.
All right.
Okay, nice.
Yeah.
So I love the fact that they're thinking about those soft skills as well as the hard skills during their after school time, because this is not classroom. They're actually choosing to spend their time like this,
Yeah.
you know?
And it's really cool to see them like have hands-on experience with like
Oh my gosh.
hardware in addition to like communicating and doing leadership stuff and learning the research side and trying to figure out all of the different components and problem solving. Yeah.
That's the best part of First Lego League for sure.
Oh yeah. For Daria and Erica, both of you have participated in events as competitors. So
With the National Center for Simulation and AOP to do the GEMS program, which is the Gains in Education of Mathematics and Science. And I was one of their lead teachers. And I was lucky enough that they enjoyed the work that I did for them to bring me back as an intern during the fall and spring. And they offered me this opportunity to coach the Stemlands, and I just had to say yes. So that's how I got involved with the Stemlands this year.
all right. And how about you, Erica?
So since sixth grade, I have been a part of the National Center for Simulation Circle, and I've been doing the GEMS summer program. And so through that, I actually had found out about NOC TSD, which is a Navy base here in Orlando. They had a first Lego League team called the Gator Bites. And so that was how I got introduced to First Lego League as a competitor. And then I was a mentor there. And with my continuation and involvement with GEMS and the National Center for Simulation, I was offered the opportunity by Lindsay Spalding to, join their program as a work intern. And with that, I was able to co-coach with Daria, the Stemlens, our first LEGO League challenge team. So yeah.
Yeah. That's fantastic. We are definitely fans of Lindsay over here. Lindsay, she has participated in our program advisory committees, which are groups that come in from industry to tell us, are we teaching the right things? And we talk a little bit about the connection between middle school, high school, college, whatever it may be. And so she comes in and gives us information about that. And then we've also hosted Starbase here at Full Sail as well. So super fans of Lindsay, shout out to her. So let's talk a little bit about how universities like Full Sail can encourage the ecosystem of FIRST Robotics. We talked a little bit earlier about things like having exposure to events, like having events on campus and having venues to be able to do that. So the live venue is a really perfect opportunity to do that. Desh, why don't you talk a little bit about, the volunteer.
FIRST nationally. FIRST is a volunteer-run organization, and it requires that partners come on board to say, yes, we'll help form teams, yes, we'll help train volunteers. In a lot of areas, colleges and universities are those partners. When I first started in 2015, Hillsborough College was the partner that came on board and said, okay, yeah, we want to grow FIRST programs in our community. Now our program delivery partner is Fungication. We're very appreciative of them. But a lot of times our colleges and universities provide volunteers at our events. Yes. Not only do they provide the venue, but they also provide mentors. So, Bex, like you were saying, you're excited about archaeology. You would be one of the mentors to help a Stemlens team find out more about what is archaeology and why does it matter and how can we do better. Colleges and universities have a wealth of knowledge, a wealth of support. But the big thing, the one thing that I think gets overlooked is that when parents and families come onto a college campus for a tournament, they actually leave learning a whole lot more about the institution itself. They find out more about the majors, more about the paradigm and the pedagogy that the school uses, and Full Sail for sure, hands-on, competency-based, making sure that the students have those portfolios, they graduate with movie credits and all sorts of other media inspiration. So I think the idea of getting more colleges and universities involved with FIRST, not only to help the young people learn more about STEM and get inspired, but also so that families can learn more about what the colleges have to offer.
Perfect. Yeah. So for any faculty members who are watching, if you would like to mentor, please reach out to us. And then also for students, if you want to volunteer, also please reach out. And we can, pair you up, and you can also be a coach or mentor. So we talked a little bit about families. How can students, especially young students, and then also maybe parents or older enthusiasts of robotics, how can they all get involved in the journey?
So, Bex, you mean the young and the young at heart?
Yes, the young and the young at heart, yes.
I actually love what you have on your display there. You have the XRP robot and you have the Smart Fun Invention set. I think for those students that are younger, being able to have a kit, a hands-on kit that allows them to explore, no pressure, just the idea of exploring what robotics is all about, because sometimes people think it's very intimidating. When our kids were younger, we used snap circuits. Have you heard of the snap circuits kits? Oh my gosh, the best, right? For building those circuits in a very easy way. For the young at heart, there are always maker fairs, right? And I think Full Sail, do you guys offer a maker fair?
We do not offer a maker fair, but there is one in Orlando.
Okay.
So we just recently had the maker fair in Orlando. I think it was not last weekend, but the weekend before, and they had a ton of robotics stuff at the maker fair.
Yes.
We actually saw some ones related to different fandoms, and there was a lot of really cool stuff, BattleBots type stuff. And so I'd love to see what we have going on in the greater Orlando area and maker fairs for sure.
And some of these kits that we use in FIRST LEGO League, we use EV3, we use Spike Prime, we use Mindstorms. A lot of those kits can either be purchased online by families or they can be purchased on eBay or some of those sites, Facebook Marketplace or something like that. I'm not promoting anything, but just to say that there's always somebody out there hoping to sell what their kids have outgrown, and now it can be time for another child. Families can start robotics teams. Schools can start robotics teams. Boys and girls clubs, big brothers, big sisters, churches. We've seen teams form in any number of fashion, and there's always resources to help out. So you don't go into it alone. And you don't necessarily have to be a techie person. You can be an English major, you can be a journalist, right? And all of the skills that you have, you can bring that to the kids and let them pick up on those skills because we use all of it in First Lego League.
Yeah, so the XRP kit, the Experiential Robotics Platform Kit, is one of the kits that you can get from First Robotics. And this one actually put together this, and it has like step-by-step videos. Like they tell you exactly where to put stuff. They tell you what to worry about, and they basically say like, hey, if you run into an issue here, just adjust. And,
not a problem.
Yeah, exactly. It's super easy, very, friendly to use, especially if you might be intimidated by robotics. This one is a really good one to start out with.
I like it.
Yeah. So let's talk a little bit about, students from FIRST. Do you see them going on to pursue engineering and simulation degrees?
Yes. In fact, there is a Brandeis study that's been done over the past 20 years for FIRST robotics programs. Students are more persistent with their majors. If they start in computer science and they've been a FIRST kid, they persist in computer science. They persist in those harder classes. And I say hard, maybe they're not hard for everybody, but trigonometry, calculus 3, and differential equations, and statistics and physics, right? Our students persist through that because they've already had experience persisting in their programs. But our students aren't just technology majors. We've seen, of course, we've seen the game developers, probably number one, right? We've seen game developers, but we also have seen students go into biology and chemistry. They've gone into entertainment just because they enjoy the process, that engineering design process across the entire spectrum of identifying a problem, creating a solution, designing it, testing it, and then sharing it with others.
That is fantastic. Next question is for all three of you. What advice would you give to young builders who dream about turning this passion into a career? We'll start with Daria.
My advice would be just don't give up. We've talked a lot about resilience in this podcast, and I feel like I can't stress that enough. You don't have to enter this field with necessarily certain background skills or anything. You just have to have a willingness to learn and a willingness to fail. And if you have those qualities, then I think you're prepared for this environment in this major, those types of things, because it can be very difficult and it can be very challenging, but it can also be very rewarding. So my only advice would be to not give up.
What kind of advice would you give Erica?
I would just say, don't be scared to ask questions. Be open to learning. And with learning, it comes failing, yes. So don't be afraid to push past your failures. As Full Sail says, to fail forward. So you want to make sure that you are still fostering your curiosity and you're asking the questions. You're not scared to ask questions because that is a big thing. You don't know what you don't know. So you want to gain as much knowledge or just skills that you can. So.
And what would you say, Desh?
I would say for parents to expose their young builders to any and everything. I think when my kids were younger, I have 5 young adults now, but when they were younger, we put them in soccer, we put them in basketball, we put them in karate, we put them in dance, and because I do have a computer science degree, we put them in STEM programs.
Yes.
And so the idea is to give your kids as much exposure as possible because you never know what they may find interesting.
That is a fantastic bit of advice. One of the things that Erica and Daria had kind of mentioned is that feeling forward. One of the things that we do here at Full Sail is to have that discussion with faculty and with students. sometimes faculty might not know the answer either. Like nobody has all of the answers to every single technical problem ever, right? But having somebody there to kind of bounce your ideas off of, to help you troubleshoot, especially if you're not familiar with the troubleshooting process, and asking questions and asking certain kinds of questions. It's helpful to have somebody there to coach and mentor you and help you, guide you along the process. And that's why it's really important to have an active part of all of this process. Is just to kind of talk through it, get hands-on, dig deeper, and learn by failing forward. Some of the things that we talk about within our classes here at Full Sail is we have a couple different programs that work specifically with hardware. We have our computer science program and our game development programs. Both take our digital logics course, and then we also have our simulation engineering degree, which takes our microcontrollers course, and they deal with a lot of this type of hardware. They will focus in on things like analog circuits and logic gate creation, but we also have some simulated areas to be able to kind of play around with. So, for instance, we give the SparkFun kit to all of the digital logic students that are doing both the campus and the online version. So we actually ship this out as part of the launch box. But say for some reason, like you are putting it together and something breaks. It's like, oh my goodness, what do we do now? You can get additional parts, but it might just be better to kind of simulate the experience as well at that point. Or if you want to play around with a whole bunch of different things, we can do that as well. So there's a lot of really cool stuff you can do. One of the examples of utilizing the SparkFun kit, we actually have, there is a student, he has since graduated and he has become a lab specialist now. His name is Cameron. He utilized extra parts in the SparkFun kit to create a sensor, a garden sensor, and we actually have some video on that. We have an area back behind Building 4, which is it is a area where we've upcycled some dumpsters to be able to have a raised bed garden. And one of the things that we find is like, it is hard work to take care of a garden.
It is.
And so sometimes it's helpful to have a reminder of like, how much water are we putting in there? How much light are the plants getting? Those types of things. So Cameron, during his time here as a student, used the extra parts of the SparkFun kit to build not only sensors, but made a companion software application where they connect and he can monitor the temperature, the moisture, and the light for various plants within that butterfly garden behind Building 4. So I wanted to just kind of show off and give a little shout out to Cameron.
I love it. I love it.
Let's shift gears now a little bit. We're going to switch to AI, which is, I think, everybody's favorite topic right now. So how are we, how are we integrating AI into robotics, and how does FIRST integrate AI?
Okay. So, we started off by introducing Jane, right? Jane is actually not a part of the FIRST Lego League competition, but she is definitely an attention grabber, right? And so what we typically do is I was a beta tester for OpenAI. I don't know if I mentioned that to you, Bex.
No, you didn't. That's super exciting. Okay.
Yeah, so before OpenAI introduced ChatGPT to the public, I submitted a proposal to be able to use their OpenAI API with my robot. And they said, okay, let's try it. So I created a program where I would try to get the robot to connect with the OpenAI.
Hello, my name is Jane. I am ready to chat. I'm connected to an OpenAI API. Please remember, my answers may or may not be accurate.
Okay. So not that I want to take away from the young people learning to code, but there is this new thing called vibe coding. It's where you work with AI, large language models, as well as with your hardware, and it reduces some of the time that it takes to program your robot. And I happen to think that although we're not using AI with FIRST Robotics just yet, that might be something we'll start to consider, especially with the older students, so that they can have those industry skills of knowing AI and knowing robotics and how to work together.
Yeah, so Daria and Erica had mentioned earlier some of the challenges that students are running into. How are they solving some of those challenges using maybe something like vibe coding?
Was that a question for us or for Dee?
Yeah. So Daria and Erica, are you seeing students use AI tools to help them code?
At the moment with our team, we have not been utilizing AI for troubleshooting purposes. I would say outside of our team, I've seen it be a very valuable tool for coding. It's very specifically like different language learning models are good, or large language models are good at troubleshooting code. But we have not used it specifically with the STEM ones yet.
Okay. All right. How about you, Erica? Are you seeing some use of, you know, large language models and generative AI tools to help with programming?
I haven't seen it in First Lego League, or at least with our team yet, but I have seen it in the Starbase lab. We another intern, he's not there anymore. His name is Daniel. He was working with AI to come up with code for one of our Arduino sensors, for to show the kids at the Starbase camps. So then there I have seen it, but I haven't seen it much elsewhere. But it is a very cool and helpful tool to use.
Mm-hmm. Fantastic. Yeah, here at Full Sail, one of the things that we encourage is using AI and generative AI tools for programming in appropriate ways so that you can help the process along, right? We don't necessarily want students to over rely on certain tools because we want you to still learn the fundamentals behind it. But there are things that you can do with AI like rubber duck debugging. So if you're not familiar with that, it's basically where you kind of if you don't have anybody to bounce ideas off of, you will sit a rubber duck in front of you and you will talk to the rubber duck and talk out the problem. And it's a very famous thing to do, famous technique used within computer science. And so we encourage AI use in that way, as being able to kind of bounce ideas off of, troubleshoot, and you can do essentially kind of like rubber ducking or pair programming with AI through that process. One of the other things that we teach here at Full Sail, we have an AI concentration within the computer science degree where we teach things like natural language processing and machine learning and computer vision. And a lot of robotics have things like cameras or eye sensors, right? And Jane can see us and talk to us, and she will move her head based off of who's talking. And so one of the things that's really kind of cool is being able to utilize those in the same way that maybe humans would be able to see each other. The camera can see each other, and they can use computer vision. Robots can use computer vision to process the image and the video data that's happening very similarly to how humans do that as well.
I asked Jane what she thinks about artificial intelligence and how it impacts robotics in everyday life.
Yeah, go for it, Jane.
Jane, are you going to answer my question? Okay, I guess not.
Artificial intelligence makes robots smarter. It helps them learn from their environment. AI allows robots to make decisions. This makes them more useful in everyday tasks. For example, AI helps robots clean homes and assist in hospitals. It also improves efficiency in factories. AI in robotics can enhance learning experiences too. It can make education more interactive and fun.
Thank you, Jane. She didn't embarrass me back.
Hello, everyone. I'm Jane, a humanoid robot created to help you explore STEM, programming, and coding. I have sensors that help me interact with the world around me. They allow me to see, hear, and respond to what's happening. I'm connected to the OpenAI API, which lets me access and share information quickly. I can help answer questions and guide you through learning challenges. I'm excited to be here with you all at Full Sail University. Let's dive into the world of technology and innovation together.
Fantastic. And we were just talking about Jane's sensors, right? And so now she can see and hear what's going on.
Yes.
All right. So we're going to now hand it off to our Q&A section. So let's start with our first question from the audience. Desh, what is your dream? What is each of the co-hosts? Okay, so we'll start with you, Desh. Okay. What is your dream to achieve in robotics?
Oh my gosh. Okay, so my dream to achieve in robotics would be to help young people see just how easy it is and how accessible it is to build these machines. I think that they're going to be a part of our future. I think our young people should have a voice in what these machines look like in everyday society. And I would really like to have an impact on getting as many young people to the table as possible.
Yes, that's fantastic. How about you, Erica?
So as Desh was saying, as the use of AI increases and the reliance on robots also increases, it's just going to be really cool and to see how more people use them. And as younger kids learn how to use them as well. So that is my dream, so that younger generations do learn how to use them responsibly and for really cool ways. So I'm excited to see how people decide to use them.
Fantastic. And how about you, Daria?
I would say my dream for robotics is just that it can be used to make the world a bit more of an accessible place for people, so that it can have lots of benefits for all types of people, and just that it's used responsibly and that we're, keeping our keeping cautious in mind. But yeah, definitely being responsible with our robots and with AI and things like that. But I just hope it can make the world a bit more accessible and have lots of benefits for all people.
I love that you specifically mentioned accessibility. That's something that we are very focused in on here at Full Sail. We have a couple different projects that we focused in on related to, like we have our SECO ladder, which is for individuals with cerebral palsy. We also have our positive cause class within our simulation engineering program. And then we have adopted that into our user experience program, which focuses a lot on accessibility and technology. So I'm very excited to hear that that is where we're all kind of hoping that robotics, the dream for robotics of where it's going. So the next question is, for a 30-year-old beginner to robotics but mildly knows coding languages, what kit would be a good place to start? What would you think? I think the XRP kit is a good start.
XRP as well, yeah.
I think the XRP kit, you could do this at pretty much any age, maybe like, I don't know if there's an age limit on the actual
8 to 108.
Yeah, right. I was gonna say it's pretty. I would say starting pretty young, and going forward. This one was a really easy, you can put it together.
What
and
does
maybe
it consist of, Bex?
It has a bunch of different sensors. So we have like an Arduino board on it. It has a couple of different components. Like some of these components are actually 3D printed. Yeah. So, and it does not come with batteries, so you will need to get batteries. And then there's different parts related to the wheels. It has these like little marble parts on it as well. But there's a lot of different components, and the biggest one is probably the SparkFun Arduino XRP board here, and that's kind of like the brain of it all. But the one thing that I would say is there's not very many parts. If you want to buy it without the 3D printed parts, if you are a 3D printer enthusiast and you have a 3D printer at home, you can actually get the files as well and print them out. Or if one of the parts breaks or whatever it may be, you can print them out again. That is something that I think is a really cool component of this. They also have sensors on the front, the camera sensors, so that it can tell where it's going. This is essentially like a little mini car, so it can and you can program it to move in a lot of different ways. So that is a really good kit that you can start out with. If you know a little bit more about robotics, this SparkFun kit is also a really good starting point. I wouldn't say like a lot about robotics, but if you already know a little bit about how the different components might fit together, this is another really good start. You don't have to, like I said, no, but one of the things that's really cool about this is it has a lot of different parts. It does have some guided projects
activities
that you can do.
Yeah, it does.
So even if you don't know, you can still kind of learn the
and
process
it starts
as you go.
very basic in the beginning. It's push this button to make the light come on, and then it goes on to potentiometer, so it goes from lighter to brighter. And so, yeah, it's really cool. And I would also say continuing education courses at local colleges. If you can find a course where they will help you with your continuing education, it never hurts.
Yes, fantastic. All right, so next question is, how do programming, AI, and simulation each contribute to the development life cycle of an intelligent robot?
I'll take that one.
Yeah, go for it.
Yes, so I always like to say we want to keep the human humanity in all of our technology. So when we're starting to think about programming, that's humans trying to solve a problem. I am not a fan of AI solving our problems. I want humans to say, here's a problem that we need to solve, and we're going to write a program and then turn it over to AI. And perhaps AI can help us write the program faster, but we came up with the solution. Yes. AI did not come up with the solution. The idea of simulation allows us to test our ideas before we actually spend money and time and resources on them. So if you're able to simulate your solution, all the better for saving money and time.
Oh, yeah. And one of the things that I think is really important, like you had mentioned, is kind of using AI as a companion rather than as the driving force.
Yes.
What we're seeing a lot of in AI is that it struggles with newer problems that we haven't quite solved yet as humans, right? Because it's pulling on information that already exists.
Yes.
So it's really important for humans to be part of that problem-solving process, especially as we're digging deeper and trying to figure out new things, right? The other thing, too, that you had mentioned is simulating experiences where it might be dangerous to do it otherwise, right? So that's part of the really important part of simulation is like I used to work in safety critical tasks, so I evaluated training for nuclear power plants and oil rigs, which are huge, like areas where if things go wrong, it could go really, really wrong, right? So one of the things that's really important is being able to use simulation and test those things out before you're spending lots of money on building these facilities and training folks in ways that will allow them to be safer along the way. And then also in terms of robotics specifically for simulation, we also have here at Full Sail, the simulation engineering students also helped build a trainer, a simulated trainer or a VR trainer for the Da Vinci robot, which is a healthcare robot.
Yes.
And so that is another way where simulation might kind of fit in. The other thing too is at Full Sail, we also do fabrication as part of our simulation engineering degree. So fabrication can include things like 3D printing. So there's also that component related to it as well. And then on the AI side, we are essentially kind of building out similar things like, artificial neural networks are very much like human neural networks, our brain, right?
Yes.
So we're kind of mimicking those specific components within the human brain. But that is another way that where AI can kind of integrate into robotics as well. And it's kind of interesting to see how things are shaping up.
I agree.
Sure. Yeah.
I think the future is bright.
Yes, it is. It's super exciting. Okay, so the next question is, how do you balance the power of AI with the need for transparency and safety in robotic systems? That's a fantastic question.
That's a great question. I was listening to a news story earlier today about the TSA agents when the government shut down, but the agents still had to work, and a lot of them were fairly stressed. And someone brought up the idea, well, just get some AI agents to do it. But the thought is the AI agents don't have that nuanced understanding of perception of what might be about to happen versus what really can happen. And so I think that concept of AI and it being very transparent about what it can do and what it cannot do is crucial. We do not want systems that we ourselves don't understand why they're making the decisions that they're making, right? So the whole, the idea that we want our companies who are investing in AI to have that nice, transparent model that we can understand and follow and can predict what will happen when an AI agent is put into place.
Yeah, and I agree. I think also just leadership in general, right? We want to kind of see a little bit of transparency just so that we can understand what's going on. If you cannot explain to somebody why you're doing something, then maybe we should think about it just a little bit more, right? And so that's the same thing with AI. If we cannot explain why AI is doing something, maybe we should dig a little bit deeper, right? And with AI, the other thing too that's really important, I always kind of say this, is AI is like a toddler. If you teach it to do bad things, it's going to do bad things, right?
Yes.
But we want to make sure that we're teaching it to do good things, and that's why things like AI ethics is really important, and transparency is part of that so that we can kind of hold each other accountable for what we're doing in that space. So Daria and Erica, how do you feel about like AI ethics in robotics?
Like you guys have been saying, I think transparency is the main thing. Trying to avoid bias in our databases that we're implementing to these AIs. But yeah, I think ethics is very important. I think it should be the main priority when dealing with robotics and dealing with AI, because you want to make sure you're providing a safe environment for people, and that you're not, even though there can be many benefits, we don't want the negative aspect of things to outweigh those benefits. So yeah, I think AI ethics should be the highest priority when dealing with it.
Fantastic. And how about you, Erica?
Yeah, I agree. Ethics should be like top priority when dealing with AI. We also want to be aware of what information we're giving it because as we know, AI and most AI platforms, they do share the information to their databases. And so when people ask certain questions, they may give information that is not supposed to be released. So we do want to be careful with what information we're putting into the devices and what we're asking it to do, because what the outcome may be, although its consequences may not affect us in the moment or at all, they may be affecting someone else, subconsciously, or if you meant to or not, they will have consequences to whatever it is. So just making conscious efforts to make like yeah.
Yeah. Be
Yeah,
careful.
and one of the things that we also talk about a lot, and Daria and Erica, you kind of both mentioned this a little bit. Making sure that you're not biasing any kind of data that you're feeding into AI. So, like we talked a little bit about before, AI is pulling off of something,
Yes.
and depending on how that data set is structured, if it's not clean, if it's not structured in a certain way, sometimes it can pull off of biased information. And even that information might be biased in the first place, like humans can be biased.
Of course, we all are, I'm
Yeah.
sure. Yeah.
So if you're including, if you're not looking at the transparency of the data as well, sometimes that can affect AI models. I highly suggest, there's a fantastic book that I usually like to give a shout out to, called Algorithms of Oppression. And it's all talking about how data sometimes can be used for various reasons, right? And we want to make sure that as we are building out new systems, we're being ethical and moral about the way that we're building out the systems and the data that we're using during that process.
Amen, sister.
Yeah. All right. So that kind of concludes our question section of the Tech Tuesday session today. But I wanted to do a little bit more of a shout out to our event on December 13th. So Desh, why don't you talk a little bit again about the details for that event?
Excellent. On December 13th, 2025, from 9 a.m. to 3 p.m., the public is welcome to join 24 amazing teams from the Central Florida area. Those teams are roughly 4th grade through 8th graders, and they've been working all season long on the 4 key components of FIRST LEGO League: robot design, innovation project, the robot game itself, and core values, a foundation of core values, those ethics that we talked about, right?
Yes.
A foundation of core values for all of our teams. That's what they're built on. It's open and free to the public. We look forward to seeing you guys at Full Sail Live. And if you want to start your own team for next season, please reach out. We're happy to help.
Fantastic. Thank you all for joining us today on YouTube, Facebook, and LinkedIn. If you're on YouTube, please like and subscribe. And we hope you all have a fantastic and wonderful day. And we'll see you all next time.